All right, in this lesson 22, we are going to talk about how to visualize sets using Venn diagrams. We learned a bunch of stuff in the last lesson, notably what it means to have a union of two sets and their intersection. So in this lesson, we are going to visualize this using Venn diagrams. So we want to shade the Venn diagrams to first illustrate A union B. So A union B is everything in A and B. So if I shade this, it would be everything in A and everything in B. So it would look just like this. All right, the next one asks for A intersect B. So here, I'm having trouble with my pen here, sorry. So if we want to find A intersect B, that's everything that A and B have in common. So in terms of a Venn diagram, this is literally where they intersect. So I am right here in their intersection. This is A intersect B. And part C asks for the intersection of A complement and B. So this is A complement, remember, is everything not in A. And then I want to find the intersection of everything that's not in A with everything that is in B. Well, here I do see that A and B have some sort of intersection, so I know that I can't shade the intersection because that is included in A, and I want everything that's not in A. So everything that is in A complement that is also in B will consist of this region right here. Everything that's not in A that is also in B. Right there. All right. In the next example, here we have some numbers going on. We have two sets A and B. And I first want to shade A complement union B complement. So this is everything that is either not in A or everything that is not in B. Let's write this down. So everything not in A and everything not in B. Well, everything not in A is simply B here, and everything not in B is simply A. So we don't have any elements outside of A or B. So here, I will just shade these two portions. So everything that is not in A is B. Oh, actually, you know what? Everything that's not in A is here in this part. Sorry about that. Everything not in A is this part right here. And everything not in B is this part here. So everything not in A combined with everything not in B is everything except for their intersection. So if I want to determine the elements of A complement union B complement, this will be -2, 4, 13, and 7. That is B complement. And then A complement will be 8, 0, -3. So this right here is B complement, and this right here is A complement. To determine n of A complement union B complement, here I can just count them. So 1, 2, 3, 4, 5, 6, 7. But I can also use my rules here. So this is the number of elements in A complement plus the number of elements in B complement minus the number of elements in A complement intersection B complement. So the number of elements in A complement, that's everything that's not in A, which is the elements 8, 0, -3. So this is 3. The number of elements in B complement are the elements -2, 13, 4, and 7. And then do I have anything that is in the intersection of A complement and B complement? Well, whoops, why did I put 7? Sorry, I meant 4. So this is equal to 0 since I don't have any elements in both A complement and B complement. So I still get 7, even using my rule. All right, one more example. We want now to shade A complement intersect B. So this is everything in A complement and B. So everything in A complement is just everything outside of A, which would be, if I were to shade that in, it would be everything, whoops, let's erase that. I am having pen issues. So everything not in A would be this. But then I want everything that's not in A and everything that's in B. So that would be all of this right here. Okay. Determine the elements in A complement union B. Well, here I can list them out pretty easily. It is 8, 0, -3. And to determine n of A complement union, intersection B, this is 3. But I can also say that this is n of A complement plus n of B minus the number of, oh, actually, we can't use this rule here. Sorry, we can't use this rule here because my rule here, n of A union B, is only valid for unions. This is an intersection. So in this case, we can just count them, which is 3. So the number of elements in both of these is 3, 8, 0, and -3. All right, that is it for today. Hopefully you learned a little bit about sets and Venn diagrams. I will hopefully see you in our Zoom meeting, and if not, I'll see you on Wednesday. Have a great day.